Hello, everyone. I'd like to thank the organizers for putting this Congress together under challenging conditions. I'd like to thank the symposium organizers for thinking of me and inviting me to this Congress. What I'd like to do today is to have a look at different aspects of protist classifications that I've been involved in over the years. Um, I've been on the botanical code and I've been on the ISOP classification committee that I chaired for many years. And I've worked with Colomán de Vargas group with UCREF and UniUC, and as well with the phylocode people on advancing on various fronts with classification and systematics and so on the last 20 years or so. So what I want to have a look at today is in very simple terms, looking back at where we were and looking forward about where we're headed and what some of the lessons are that we've learned, and to use this as an opportunity for us to contemplate the hurdles before us and the sort of things we want to do more of and the sort of things we want to do less of. So if we think about a very simple system like this, where we have several species arranged in several genera, and then they can be grouped into families and orders and so on. In linear terms, it ends up looking like this, where you have your ranks, and everything looks fairly easy when this is what you're dealing with, until you actually start trying to assemble not just one clade, but many clades and bring them together and try to see how they fit. And that's where things get tricky. And you also have to realize how much of doing the classification with ranks becomes arbitrary. And so that's one place where you'll probably see me refer back to several times. This is another situation that arises where we have one species, so it's a monotypic group, and a phylum is erected for this one species, and these also are kind of a different way of having a problem to address. This example that I'm giving here with the Ciliophora, I think most people will recognize these as being a good phylum. And to reach the family Tintinidae and then the group genus Tintinus, you need 11 nodes. So it seems like a lot, but it's entirely possible. If we look back at this 1993 paper with that Tom assembled, you will remember a variety of things from it. I wonder how many people remember having to memorize this in the day. But he introduced a variety of new terms in order to be able to assemble that. And if we look at these, we have several for kingdom, we have several for phylum, and it gives us about 1 to 20 groups. And if we wanted more, there is no reason why we cannot insert, for example, an infra-order and a parv order and so on, and have even more than 20 to accommodate our needs. So these sort of things are possible, and we can come up with rank names. But one of the features of this that became problematic is that in a way, not only was there a tour de force of trying to come up with an evolutionary scenario for the protists then, but it was too much and too soon. Because if you look at this paper from 1988, Tom's paper was December 93. In this short number of years, our ability to handle molecular phylogenies and build trees with eukaryotes was still in its infancy. There wasn't a lot of taxon sampling. There was a lot of exploring which sequences are good for phylogenies, long branch attraction issues that were not yet well understood. Bioinformatics was still in its infancy. Many misidentified cultures, contaminated cultures that were needed to be sorted through. And so, looking forward about what we learned from these exercises in the 90s, there are some lessons. One is that speculation really belongs in papers; it should not be in the classification. Um, and you need to stick to the facts from the trees. You have to be disciplined enough and have conversations about which nodes are robust, which clades are monophyletic, where the uncertainties are, and what is just plain speculation, and try to keep those things separate and some of it out of the classification. Another important lesson was just don't do it yourself. It'll be your classification, and it's not very useful. It really has to come from the community. It has to come from the specialists who are familiar with these organisms, and they have to come to an agreement, group by group, about what we agree on, and we need to identify all of the aspects of this that where we do not have agreements. So as we're looking at the early 2000s, there were some real obstacles, and these are not trivial because we have different cultures. Zoologists, mycologists, microbiologists, botanists are different. We have different languages, and there are different traditions and ways to do things within subdisciplines as well. And people do get very upset when you fiddle with this stuff. What culture you were brought up in you is important. Your colleagues you meet at particular conferences, their friends, which classification you were taught, which words were used, what vocabulary you have learned. These things really stick in your head for years. And it becomes harder to unlearn and relearn a classification, especially when the terms change a few times a year or once every 2 or 3 years. At some point, this is really not easy. And the reason why it's difficult to learn and relearn everything is because you're actually changing the story with which you've assembled a classification in your head. The other issue I want to talk about is what I call the lenient curse of moving a clade changes the name, it changes the authority. If I pick on Paramecium without offending anybody, this is an organism that has had a lot of research done with it and books written on it. Um, if for some reason it has to be moved to another genus, it becomes Socasia aurelia, and the name changes. And then if for some reason the family has to change as well, now we have Stochassia aurelia that's not a paniculid anymore, it's in another family. And you can see how quickly things become problematic because who changes, and suddenly it will become harder for these to be tracked in the literature. If you don't know that Stochassia aurelia used to be Paramecium aurelia, do you know to go looking for it as Paramecium aurelia? Uh, Especially if it's not an organism that has had a lot of research done on it. And when it's in a different family and with a different genus name, these things become harder to find 10 years later or after 100 years of changes, when many of the papers are in journals that are not necessarily very easy to find. And so the vocabulary and grammar that we use in doing this sort of things does matter, and keeping things steady and stable does matter. You can think about what happens if every now and then you have to call a chair a car, and then suddenly that changes again. You have to call it something else. At some point, your language for communication is not that useful anymore. And if you have to change the grammar or the language as well when you change code, this becomes even more difficult. So there's something comforting about knowing that a chair will still be called a chair when you move it to a new room or if you move it to a new building without having to learn new languages every time you do that. I'm going to give you one example with this paper, 2006, which kind of makes the point a little bit. Most of us work with organisms that nobody pays too much attention to. But there are some that really matter. There are some that come with a lot of standardized protocols, regulations, um, and when you change those, it's problematic. Like this example here, where suddenly we had a situation where there was invalidation of names. There were a problem with the type specimen that were acceptable in one code but not in the other code, and how things had to get redone to the point where the botanical code had to make exceptions and accommodations or rule changes to accept this shift of a group of organisms from zoological code to the botanical code. So never mind the trees and building trees and so on. What happens? What do we call all these things? On the one hand, we have a lot of new names that were being introduced, ephemeral names, transient names that were retained for a long time, and different labs developing different vocabularies for a couple of decades. Sometimes grad students at conferences were unaware that the names used by this group to call this clade was the same that even though the words were different, it was the same clade that they were talking about. And so it does become confusing after a while when you're not familiar and you haven't kept up, or you're late being introduced to all of these changes that were occurring in the 90s and later into the 2000s. So the other issue is the ranks, what to do with the ranks. There really was no agreement on what to call them. It was easier to bring a group of people together to agree on the order and on the nodes, uh, but much harder to get agreements on ranks and how to call them, which rank to give them. So after some time, I think we ended up making a decision that ignoring the endings of the names was the simplest way to retain the name, and not changing the name was important. And we ended up trying to re-identify the oldest correctly grouped genera, and that took some effort by a lot of people to try to refine what these were. And then that's how we ended up with those darn bullets. If anybody knows how problematic they are, I'm the one who has had to format those year after year. It's not so bad when you're dealing with 3, 4, 5, 6, but when you have 10, 11, 12 of them, these this becomes a difficult way to communicate again. This, as an example, is from the Handbook of Protists that was published a couple of years ago with colleagues John Archibald, Alistair Simpson, Claudio Slamovitz that were the editors for this. And you can see how the bullet are retained in this, but the authors used chose where they wanted the starting point to be. So for the reds, they started with 2, so the red algae being, I guess, 1 bullet, and then here with Streptophyta being 1 bullet. And this is nice and simple when you're working within one group. The problem begins when you're having to assemble these groups together, and they have to come together at a node, and you have to try to work out agreements on where they actually fit, because not everybody agrees on that. That's usually where there are discussions. I'm going to illustrate this in another way, and looking at ways to address this and move forward. If we look at this uh, again, there are one way to assemble it is to start with genera, where we group them into families and so on, but quickly we run out of ranked names unless we introduce a whole bunch of them. And so if we know that for Ciliophora we need to reach that top node there, and we want this to be a phylum, then we need to introduce all kinds of terms between the family and the phylum here to make the P reach over here. And so that becomes a little bit arbitrary about which rank you call what. Are you going to have a bunch of subphylum levels, or are you going to have a bunch of suborder levels to reach there? And this is the arbitrariness that creeps in The other thing is you can start from the top, where you can say, well, I'm going to start with eukaryotes, or I'm going to start with alveolata. And that's, I'm going to call that a kingdom. And I'm going to introduce terms so that my P is over here. And then I need to introduce terms so that my P here, I need to get to down here for genus, and I need to introduce so many ranks. So that's kind of another way of doing it. But we know where the genus is, and we kind of have to work towards the family and genus one way or another. And both of them require introduction of arbitrary terms. And then another problem we encountered that I showed you just earlier is this, where you have monotypic groups or very small groups that are also in the tree, for example, as a family or as a genus, but they don't really have all of the other ranks. And this is interesting because that's the kind of the lawless part of it, where it's outside of the codes of nomenclature. On the one hand, there's no requirement for this, there's no need for this, but on the other hand, people really want to put it in, and it allows you to do all kinds of stuff. So, my species is very important, and so it's a kingdom. These are nice things that make your local press happy and your university president happy, but doesn't really advance anything. Uh, and then we have 5 genera in one family, but you want it to be a phylum, so you insist on including a whole bunch of ranks that are totally unnecessary in order to make this seem more important. And so it leads us to think about certain things like a classification is not a phylogenetic tree. They actually have different purposes. And I think it's important to keep these things in mind. A classification is for learning, it's for teaching. It's a way of organizing a lot of information in your head so that you can retrieve it. And so on the one hand, it has to be usable in that way. A phylogenetic tree tries to reconstruct the evolutionary history of a group, or the protists, for example, and you will end up having quite a lot of nodes and stems and branches. But does it all need to be turned into a classification, and do all of the nodes need to be named? I think often we need to accept that not all nodes necessarily need to be ranked, even though all the nodes need to be named, probably. I had a colleague last week send me an email saying he couldn't make any sense out of the ciliate classification because he wasn't familiar enough with it, and all those bullets, he couldn't figure out which were the important ranks. And so I had to send him a simplified table where you kind of list the classes and the orders and help to try to get people oriented. So that's a very real problem with the bullet system that we're going to need to overcome one way or another. So for research purposes, it probably is fine, and we can have as many bullets and nodes as we want. But it really ends up creating an opportunity for two different kinds of classifications. One that is used for research that does represent all the nodes as accurately as possible, and I think that's what we tried to do in the 5 and 12 and 2019 revisions. But another kind of classification that's much simpler that can be used for teaching and for learning and educating, and also for us for remembering and learning. So some uh, in things that we addressed in the revisions that I want to touch on. One was identifying a variety of misused poorly used terms, often in papers, and we listed some simple ones that we defined in 2005. In 2012, we realized there were a lot of poorly used terms with regards to motility and forms of pseudopodia. So we defined those. And then in 2019, we tried to make better use of the environmental sequencing information, and we defined functional groups and terms used for feeding, which became an appendix 2, where the trophic functional groups were assigned to all of the clades, and in some lineages we went as far as we could into genera. and identify what kind of feeding happens. Uh, we also introduced the number of genera in table 1 together with the probable Linnaean ranks, so phylum, class, some orders, and so on. So I think that's a good place to go to get oriented with regards to the bullets in the actual paper. Last, there was an interesting accomplishment here with the Chinese script, and I wasn't sure if we were going to pull it off, but um, we managed to modernize the script used in Japanese and Korean and Chinese to describe protists because it hadn't evolved over the decades, and there were many very old terms used to describe new um, clades. And this was, I think, a good thing to have done. So I'm going to mention a couple of other projects here. One is led by Colomban de Vargas with funding from the Moore Foundation, and it's called UniUke. Most of you are probably already engaged in one way or another with this or use it. And if you don't, you please have a look at it because this is quite important. And I will point to this curated database called UCREF that comes out of PR2. And the other one is this screen up here, which should be a searchable database. You can add your queries. If it identifies something, a picture, an image of the bug will pop up, and it will give you some kind of classification of where your bug is with respect to the rest of the classification. So this is a developing project that will, I think everybody needs to be contributing to. The other one is Regnum, and this is a repository for clade names written in a phylogenetic language. And it's very easy to use. You go in there, you get a registration number for the clade you have entered, and that makes it legal, and you can publish with it, and you will have your clade described in a phylogenetic nomenclature validly. So some recommendations going forward about things that we've learned and things that were problematic each time we tried to work with all these words and terms used for the nodes and the branches is to be more diligent in how you write your phylogenetic hypothesis so that the hypothesis can be defeated when the facts change and new data comes in. You have to be able to if the hypothesis is defeated, then it means the evolutionary scenario was false, and the name for the failed group goes. So there are ways of writing these things that make them better. The other one is for clades. If you have a monophyletic clade, you can define the branch or stem so that this group exists if these things are in it. There are several ways of doing this, and it applies irrespective of which node you hang it on. So this is useful as well, so that the name doesn't change every time you move it, and you can move it from one node to another, and you're still dealing with the same thing called the same way. So some advantages really are about of using hypotheses for evolutionary scenarios is that the names don't change. And they're well defined so that you know when it applies, and if the tree changes, then you know that the name doesn't apply to that grouping because that grouping was false. And it shifts the focus more on developments in phylogeny and avoids putting the focus on what rank the clade is named at. So it avoids all those name changes, and I think that's the most important thing to come out of it going forward. And avoiding using those endings is a big deal, or you just don't pay attention to them. But separating the clade name from the rank name is an important development. And if species need to move, there are ways of doing that as well, and there are solutions that have been addressed. This paper is worth going back to, where everything I'm saying today was kind of discussed a lot more. So to finish up, I'm going to give you some examples of what formally things look like in phylogenetic nomenclature. One is a node-based definition that is called a minimum clade definition, and it associates with the smallest clade that contains two or more internal specifiers. And it can be written various ways. As you can see, one of them is the smallest clade containing A and B, and it can be abbreviated this way for shorthand, which is useful. And another example is for defining branch or stem, which is called a maximum clade definition. And this is it associates with the largest clade that contains one or more internal specifiers, but does not contain one or more external specifiers. And so it sounds complicated, but it's simple. You write it as the largest clade containing A, but not Z. And this is the abbreviated version for it. So the final code is a rankless system without categorical named ranks, which is the system that we developed and used in in revising the classification. It's a hierarchical system. The clades can be nested. Some clades are more inclusive than others. The final code was published in May, just last year, and it has 21 articles in all, so it's not that big. And these are some examples of other terms that are used and defined there for special case situations and so on that might be encountered. And last, as I finish, this is the book of phylonyms that has all of the existing clade names for plants, animals, and fungi, and protists, and everything translated into phylocode nomenclature. And Alistair really has to be credited for doing the bulk of the protist translations into this book. So I think I'm going to finish here, and I look forward to receiving your questions next week. And it's too bad I can't see you face to face here as I speak. Thanks.